So in the previous solution, we discussed the derivation for the center of mass of a quadrant of a quarter of a circular disk using the polar coordinates. Now this time let us derive the same using Cartesian coordinate. So the area here dA, the elementary area dA here would be equal to dx dy, which in the case of polar coordinate was r dr d theta. So this is the primary difference that should come into your mind while using polar or Cartesian coordinate as r dr d theta and dx dy respectively. Okay, so that is point number one. Point number two, before we stop the derivation, would be to understand this curve here. What does this curve represents? See, this curve is actually the portion of a circle which is represented by the equation x square plus y square is equal to a square, and therefore y is equal to root of a square minus x square. All right. So if you consider this first quadrant alone, and if you draw a vertical strip here, okay, a vertical strip here, and name it as ABCD, okay, naming it as ABCD, like this. Okay, so we have AB and CD. Now, what would be the sorry, my bad. So now what would be the value of y in DC? At DC. So at DC, we can say that the value of y is equal to 0. Why? Because DC is a line which is along the x-axis, and any point on the x-axis will have the y coordinate equal to 0. Similarly, what is the value of y on this curve AB? See, this value y will be equal to the value derived from this equation, which is root of a square minus x square. So we have a strip which has one end on the x-axis, therefore the y coordinate is 0. The other end on the curve with the y coordinate as root of a square minus x square. Now comes the really important part here, which is about the visualization of this integration. So basically what we do here is we integrate, we just add these strips, a lot of strips. Strip number 1, strip number 2, oops, my bad, strip number 2, strip number 3, strip number 4, 5, 6, and we do this complete integration. Okay, so we just add these strips. And how do we add this? We add this and we get the area dA is equal to dx into dy. But how do we add this? We add this by doing the process of integrating this along integral dx dy. Now this time it should be very clearly double integral dx dy, because we are integrating it along both dx dy as well. Okay, go through this visualization a couple of times, things will become really clear to you. Okay, now also when you are thinking about this integration, make sure that you compare the visualization of what we did in the polar coordinate with what we have in the Cartesian coordinate. Once you make your note on your own by drawing and comparing these two, things will become really clear to you. And the next time when you get a question out of nowhere for the center of mass, even if you forget things, well, of course, it is not practical for a JEE main because you hardly get 3 to 4 minutes to solve a question. But if you are in a state where you can spend some time to derive the answer, or maybe in the JEE advanced question, where you can use this concept of integration, multiple integration, to solve questions. All right. Okay, so that's it with the part of visualization. Let us now move into the integration. So what is x bar and y bar? X bar represents the x coordinate of center of mass of the quadrant of a circle, which will be given by double integral x dm by integral dm, and y bar will be given by double integral y dm by integral dm. Now again, my bad, this should be double integral dm and double integral dm. Why? Because we have masses along x and y axis. Now we know that the mass density sigma is equal to mass by area. Therefore mass is equal to sigma into area. Therefore dm should be equal to sigma into dA. dm should be equal to sigma into dA. But what is dA? It is dx into dy because it is Cartesian coordinate system, right? Which means if I were to write integral 0 to m dm, it would mean double integral along dx and dy. Dm will be replaced by sigma into dx dy, right? Now we have the limits 0 to a and 0 to root of a square minus x square. To understand which, we will have to come back to the diagram. X here varies from 0 to a, which means x equal to 0 represents the first strip and x equal to a represents the last strip. When I say first and last strip, we're talking about this complete area being divided into, not these strips, divided into infinity number of strips, right? So every strip becomes one single line then, which varies from x equal to 0 to x equal to a. And every strip will have the y point as 0 and the upper point of the lower limit as y as 0 and the upper limit as y as root of a square minus x square. And that's how we get the limit here as integral 0 to a along dx and integral 0 to root of a square minus along dy. Okay. Now the rest of this solution is purely integration, application of maths into physics. That's it. We're done with the physics part here. All what is left is the mathematics part. So the next step what I've done here is everything else remains the same except for the fact that dx dy is replaced by dy dx, and irrespective of which format you choose, you will get the same answer. Okay. So now you might be wondering, why did I take dy dx instead of dx dy? If you need an explanation for that, try doing this question based on dx dy. You will understand it on your own. Okay. And if you don't feel it comfortable while solving the question with dx dy, write to me. We'll discuss in detail why. Okay. But since you're preparing for the JEE mains, I think things should be very clear to you in terms of the the mathematical angle here. But anyway, if you, that's up to you. Now, if you're doing this using dy dx, this is what happens in the question. I add another bracket here. Why this bracket? It is just to make sure that you understand that I'm first operating only within this bracket, which means I'm operating only along dy. And when I operate along dy, I see that sigma is a constant because dy is the variable. So I can take sigma out of the integrand. So what we have is root of integral 0 to root of a square minus x square 1 dy. What is the integral of 1 dy? Integral of 1 dy is y varying from 0 to root of a square minus x square, which when applied gives y replaced by upper limit root of a square minus x square minus replaced by lower limit 0, which gives us sigma into integral 0 to a root of a square minus x square dx. Now, why dx? Because dy is already integrated. So the next step, the only difference that I've included here is that I have removed this bracket. Why? Because now you don't have dx and dy, only you have you only have dx with you. So what is integral of root of a square minus x square? We know that is equal to x by 2 into root of a square minus x square to a square minus x square plus a square by 2 into sine inverse x by a. Now how did we arrive at this? That is basic integration that you learn in class 12th. Now if you are watching this solution while you are in class 11th, most of the things that have been said here, if you don't have the idea of basic calculus, things will become really difficult. But I presume that since you're preparing the JEE mains level, mathematical tools should be ideally very handy with you. Anyway, if you're not, try finding out the integral for root of a square minus x square and you have this formula directly. Now once we have the integrand, we can apply the limits, which is 0 to a. Upper limit x being replaced by a. x being replaced by a, x square by a square, x by a. Lower limit minus. Always make sure that when you apply this lower limit, check for this minus here. This is plus, so minus into plus will become minus. Okay, so x is replaced by 0, x square is replaced by 0 square, x is replaced by 0. Okay, now let's see what's happened here. So a square minus a square is 0, so this term becomes 0. 0 into this term becomes 0. So the only terms left here is sine inverse a by a, which is sine inverse 1, sine inverse 0 by a, which is 0. So 0 plus a square by sine inverse 1. Sine inverse 1 is pi by 2. Sine inverse 0 is 0. So the only term out of this 4 term left here is sigma into pi a squared by 4. Now let us try to make sense out of this expression. What does this mean? This means that, another way of looking at this would be 1 by 4 into, right, 1 by 4 into pi a square. What is pi a square or pi r square? This is the area of the complete circle. Area of the complete circle. Now, what we actually have derived, what we have proven mathematically, is that area of a quadrant is equal to 1 by 4th area of a complete circle. Okay, so really important. That's the takeaway from this this integration. In fact, if we integrate this from 0 to 2 pi, what you get is pi r square, and that is how we get area of a circle is equal to pi r square. This is how we appreciate the concept behind these questions, right? Okay, which actually is really important. And the reason why we don't do that is we always prepare to solve the questions in less than a minute. But we rarely try to do this. Okay, anyway, now coming back to the question. So we have x bar is equal to double integral x dm by integral double integral dm, and double integral dm is what we have evaluated as m, which is equal to now I can replace this, right, which is equal to what? Which is equal to sigma into pi a square divided by 4. Okay, so if we write it this one more time, this becomes x bar is equal to double integral of quadrant of disk x dm divided by m. Right, now the only thing I've replaced here is replacing dm by sigma into dA, right? And then since sigma is a constant and since m is a constant, I've taken sigma and m out of this integrand to put it as sigma by m into integrand double integral over the area of the quadrant of disk x dA. What is dA? dA is dx into dy. Now the area of the quadrant of disk can be evaluated on the limits of dx and dy. How? Limits of dx varies from 0 to a, dy varies from 0 to root of a square minus x square. And like we did in the previous the derivation for the denominator part, we will switch dx dy to dy dx, so dy varying from 0 to root of a square minus x square. Now what I've done here, everything else remains the same except for the fact that I have included a bracket here, which means I'll be acting only upon what? Only upon dy. Now when I choose dy as a variable, x is a constant, which will therefore go out of the integrand. Integral of 1 dy is equal to y, varying from 0 to root of a square minus x square. Applying the limits, this becomes root of a square minus x square minus 0, which is root of a square minus x square into x. Now do we need the bracket here? No. Why? Because there is only one variable, which is x, and the integrand is a function of two functions, product of two functions, both of them having x. Can you integrate now? Yes. But can you do that directly? No. Why? Because the integration becomes really difficult. So you can either choose to do this using the substitution for x equal to a sine theta and then try doing this, but that would become a really a tedious thing to do, because you'll have sine cube theta and the components coming into it, which will make the derivation more complex. So instead I've chosen root of a square minus x square as u. Okay, now differentiate this equation. Differential of a square is 0, differential of x square is minus 2x dx, differential of u is du. Okay, now as soon as you make a substitution, the next thing to do would be to find the corresponding limits. So if a square minus x square is equal to u, where x varies from 0 to a, the lower limit x equal to 0 in this equation gives you a square minus 0 is equal to u, which gives you u is equal to a square when x equal to 0. When x is equal to a square minus x square becomes a square minus a square, which implies u is equal to 0 at x equal to a. Therefore, x equal to 0 to a corresponds to u is equal to a square to 0. Write this a couple of times. Change this with cube or x cube or for the fourth power and try finding out these variations. Things will become really easy to you. Okay, right. Now after substituting a square minus x square as u and minus 2x dx as du, we can see that the integrand has only x dx and not minus 2x dx. So to solve that issue, what I've done is I'll multiply this complete integrand by minus 2 and divide it by minus 2. Okay, so now what is minus 2x dx? Minus 2x dx is now equal to du. What is a square minus x square? It is u. And therefore, what we get here is sigma by m into 1 by minus 2 into root of u into du. What is integral root u? It is u to the power 3 by 2 the whole by 3 by 2, varying from limit a square to 0. How did we get a square to 0? We have discussed that in detail over here. Right? Now, once we have this limit, we can apply the upper limit minus lower limit. So I'll take 1 by 3 by 2 as constant and multiply it as 1 by 3 by 2. Upper limit is u to the power 3 by 2, which means 0 to the power 3 by 2 minus u is replaced by a square to the power 3 by 2. This becomes sigma by minus 2m into a square to the power 3 by 2 is a to the power 2 into 3 by 2. 2 into 3 by 2 is 2 by 2 is 1 is a cube. Don't forget this minus symbol over here, right? Into 1 by 3 by 2. Now, let us complete this m here. What is m? We can replace m was root of double integral dm, which actually was double integral dm in this question, which we found out to be sigma pi a square by 4. So I can replace this m by sigma pi a square by 4, right? And I'll rearrange the equation to make sure that you get the best of the clarity here. So sigma by sigma becomes 1. Okay, I can write a cube and a square, a cube by a square, into 2 by 3, into 2 by 3, and pi remains 1 by pi. 2 by 4 can be grouped as 1 by 2 by 4. Okay, now let's do the simplification. Pi by pi is 1, a cube by a square is a, 1 by 2 by 4 becomes 4 by 2, right? Wait, did I miss anything here? This becomes 2 by 3. Yeah, so 2 by 2 is 1. That becomes 4 by 3. Yeah, so what we get is x bar is equal to 4a by 3 pi. And since the figure is symmetric, we can say that y bar is also equal to 4a by 3 pi. Okay, that took really long time to explain these things. So things are complex because it was a really way longer integration, because I try to make sure that every step was explained to you clearly. And in this part, I think the most important step is to understand this transfer of limits from a square minus x square to u. All right, so that's the end of this derivation. I think we have 3 to 4 questions which are based on derivation of other. Well, actually, these are not derivations for the JEE mains, but we're just going one step ahead of JEE mains, the question side of JEE mains, to make sure that we are prepared for if in case any additional questions come up, or any additional any questions that comes along the line of the previous year questions, but one step ahead of it. So we're just trying to be safer, in the safer end. All right, moving on to the next question.